Equations, let's go ahead and take a look at the graph first of all. So make sure that you change the mode right here to be parametric for graphing. Then when you go to y equals, it's going to say x equals and y equals for the first function. So that's going to be 2t minus 1 and then t squared. And when you go to the window, since t could be positive or negative, I need to change this to say something like t will range from -10 to 10. The x values, well, this right here, since it's squared, is probably a parabola. So perhaps 10 to 10 for x and y is a good idea. Yes, that's a parabola. Okay, so we've got that one, and the other one is going to be, so this one had y squared and x was not, and it was a parabola going up. This one has the situation reversed, so this is probably a parabola going sideways. 2t squared minus 5 for x, and y is a 5t, and it's a parabola going sideways. So there's seems to be one intersection point here and one over here. I need to change the y values, go up, say, to 20. So we've got these two parabolas. One of them is going up, and one is going sideways. And we're going to be looking for the intersection points. It seems that there's two. Well, if you look at this part, we basically have two equations. We're going to have, at this point, the x values are the same. X equals whatever this is, -2 or something like that. So we'll have to set the x equal to the x, and then the y equal to the y. So when x equals x, that would give us 2t minus 1 equals 2t squared minus 5. We can then do the quadratic formula, so move everything to one side. 2t squared minus 2t, and then it's going to be minus 4. Or you could divide everything by 2 and make the numbers smaller. So it's going to be t squared minus t minus 2. Oh my goodness, that even factors. So t, and then for a -2, we'd need -2 times a positive 1, and then the middle term would be -t. Okay, so for this we get t could be at -1, t could be at 2. So perhaps that right there is going to give us both of these. Let's check. So you go to the graph and just go to trace and check when t equals -1. So as soon as you start typing, it's going to say t equals whatever you say. So we'll do t equals -1. And that intersection point is not an intersection point. So at this point, I should go and check my algebra. The x's set equal to each other. I need to subtract 2t. I need to add 1 to both sides, so this is right. I divided everything by a 2, which is legal. My factoring seems right. So it just seems that, although the algebra was correct, this one doesn't work. All right, well, let's try the other one. T equals 2. So trace, t equals 2. So that intersection point is not an intersection point. Huh. So that didn't seem to work either. The other thing you do is set the y values equal to each other. So we've got t squared equals 5t. You could move this to the left side, so t squared minus 5t is equal to 0. Factor out a t, and it seems like the intersection points are going to be when t equals 0 and when t equals 5. As we saw from the last one, you definitely need to check it. So t equals 0 is the intersection, no, that one doesn't work either. And 5, that's not even on the graph, that's way up there at 25. So it seems that these two actually don't intersect. This is something that does not happen when you have Cartesian coordinates, or in other words, if you just have y equals x squared and x squared equals 3y, things like that. When it's like this, there is no parameter t. It's just, this is an x and a y. If the two graphs cross, then you would find the x and the y. But this has the other variable of t, which you could think of as time. So as time passes and as something is going along this parabola, did it get to this point at the same time that the red one got there? It seems from all of this work that the answer is no. You can also verify that by looking at the graph. So I'll regraph it. This controls how accurate and how fast the graph is drawn. So if you make this a small number, then it's going to draw it slower and more accurately. Mostly I want it slower because I want to see, do these things get to these black dots at the same time? If not, they do not intersect. So regraph it, and do they get to those intersection points at the same time? Wow, that really slowed it down. So there, no, they didn't get there at the same time. And there, no, they didn't get there at the same time. So as far as parametric functions, they do not intersect because they don't get there at the same time.